Well, hello everyone and welcome back to the channel. I hope you're doing fantastically well. Today I thought I would do a proper video instead of just dumping my stream VODs. And for this one I thought I would show you how to install kubeadm from scratch on AWS EC2 using Terraform and Ansible. I thought it'd be a fun project to start with. It's going to allow us to see how to use infrastructure as code. We'll do a bit of cloud automation with and provisioning with Ansible, and we'll look into some AWS architecture patterns too. So yeah, without wasting any more of your time, let's crack on. All right, so I've drawn a diagram, right? Created a diagram to illustrate sort of the architecture and how it's going to look like. So it's not very difficult. It's not very complex. What we'll have is we'll create a custom VPC, right, to encapsulate all of our resources. Inside that VPC, we'll create a subnet. We'll also add an internet gateway and a custom route table, and that's going to be to allow traffic to go to the internet and to accept traffic from the internet, right? We will associate that route table to the subnet, which is going to make it a public subnet, right? Once we do this, we'll create security groups. So we're going to have 4 of them. One is going to be for the common sort of maintenance administration ports like SSH and HTTP and HTTPS. That are going to be used for downloading packages and updating the system and all the rest of it. We'll have a security group for the control plane, for the Kubernetes control plane, because Kubernetes requires the control plane to have a certain set of ports open. Same thing for the worker nodes. And then we'll have a security group for Flannel. And Flannel, if you don't know what Flannel is, it's a CNI plugin for Kubernetes. So it's container network interface, and it handles the networking details and complexities for us. So once we have that, we'll create a key pair, right, to be able to connect to our EC2 instances, which we are going to create inside that subnet. So we'll create 3, so we'll have a basic, very basic sort of 1 master node and 2 worker nodes type architecture. So we'll have a control plane and we have 2 worker nodes. The 2 worker nodes are going to be T2 micro instances, so they're going to be part of the free tier. Now all of this is going to be free, of course, except the control plane, which we're going to set to be T2 medium, because again, the minimum requirements for a control plane node is, I think, 2 GB and 2 CPUs, something like that. And the closest and the cheapest EC2 instance that sort of fits the bill is the T2 medium. Now it's not that expensive, and we're not really going to be running it for more than, a few minutes, so it's not going to cost us much. But keep in mind that you may incur costs for that, albeit minimal, very minimal costs, but still. Now, before we start working on the code, there are going to be some prerequisites, and I'm going to make a few assumptions. Number 1, that you have Terraform installed on your system. Number 2, they have an AWS account, of course, and that you have the AWS CLI installed and configured. Now, if you've never done this and if you don't know how to do it, please let me know in the comments, and I will gladly make a video to walk you through the process. You also have to have, of course, Ansible installed, because we're going to use Ansible to provision these EC2 instances. And you have to have, I suppose, some working knowledge of Ansible to sort of be able to follow along. Now, this is going to be divided into 3 chapters. So we're going to have, first we'll handle the networking aspects, so we'll create the VPC, the gateways, the security groups, and what am I doing? We'll create security groups and all the rest of it. Then we'll move on to creating the instances, and then after that we'll spend a bit of time crafting our playbook, Ansible playbook, to be able to provision our instances. And then once everything's done, because I already have kubectl installed. Another prerequisite is going to be kubectl, the kubectl or kube control, whatever you want to call it, CLI to interface with Kubernetes clusters, to be able to, of course, interact with our cluster. And we'll deploy a sample application, and then just to test and verify that it all works. So yeah, let's get to work. All right, so the first thing we need to do is we need to create our project. So we're going to set up a folder structure, we'll create the files, and then we'll set up the basic AWS provider. So we'll go to temp, right? And then we'll create a directory called kubeadm terraform Ansible demo. We'll cd into kubeadm terraform Ansible demo like this. All right, so we're going to need to create 3 files, right? So we're going to need to create main.tf, right? We'll have an outputs.tf, and then we'll have a variables.tf for now. So the variables is going to be of course housing the variables, and in outputs we'll use that to print out some of the values we may need to use in the future. But we'll focus for now on the main.tf. And so the first thing we need to do when we create Terraform infrastructure is we need to add a provider. So we'll hop to the Terraform registry like this. So that's not the Ansible provider that we need, although we will use that later on in the video. What we need is to scroll down to AWS, right? So let me zoom in. We'll click on use provider, and we'll copy this, right? We'll copy this whole thing. We'll come back here, and then we will paste that. So we have a required providers. So this is the Terraform block, the main block, right? We specify the required providers, and we can have as many as we want. In fact, we will add the Ansible and another one when we get to it. And then this is the configuration options for the AWS provider. And so in here, we can add things like, let's see, do we actually have something? Well, region. Configure the AWS provider. We can add version. We can add region. Let's see. Authentication. Right, so we can authenticate. We can add an access key and secret key. You can specify those, but we don't really need to because we already have our AWS CLI set up. So we're only going to be worried about the region here. Right, so we'll set it as US East 1. It's not the closest to me, but it's the easiest to work with. Right, so once we have this, we need to initialize the Terraform project by running terraform init, and this is going to install the provider. As you can see, finding hash called AWS version matching. It's installing right now and downloading it. All right, so now we can start working because it's all working as expected. So we've got the provider installed, and now we can start making changes and creating our infrastructure. So we need to go back to our diagram, right? And as I said, we were going to create a custom VPC. So let's make note of that, right? We'll add one, we'll create a custom VPC, right? So we have that. We'll create a subnet. Oops. We'll create a subnet. Oops. We'll create an internet gateway. So we'll create an internet gateway. We'll create a custom route table. We'll associate the route table to the subnet. And then we'll create 4 security groups. So 5, 6, create the security groups, right? And I think that's it for the networking part of this, right? So this is it for networking. So we'll go note networking related resources, like that. And then we'll have another one for the instances, instance related resources. And we'll have another one for Ansible, so Ansible related resources, like this. Okay, so we're not going to be worried about creating modules and everything like that. Everything will be inside this file. Of course, you'd want to look into how to use modules, but this is a very basic tutorial, so we're not going to get into too much detail on that. So let's crack on. We need to create a VPC, right? So first thing we need to do is go to the docs and type in VPC. Now, you'll notice inside the documentation, so there's a search box, and every single resource is prefixed with AWS. So we can do AWS_VPC, right? And then we can sort of scroll down all the way down to, I think it's going to be VPC for us, right? Yep, there we go. I missed it. Virtual private cloud resources, AWS VPC. There we go. Right, and so now we've got like basic usage examples that we can copy and paste. So let's do that. Right, we'll copy this right here, like that. So that's going to be our kubeadm demo VPC. All right, so the CIDR block we'll use is we'll leave the default 10.0.0.0.16. What we need to do is we need to enable DNS host names, and we need to set that true. And the reason is because, actually, before I do this, let me quit and open it again. Enable DNS host names. Yep, now I have the autocomplete. So enable DNS host names, we'll set that to true, right? And this is important for Kubernetes cluster to work properly in kubeadm. And we'll add tags. We'll add a name for the VPC, and we'll do kubeadm demo VPC. And that's it, really. We don't need much else. So the way to deploy now is to first of all run terraform plan, and as you can see I've got it aliased to tf, but you can run terraform plan, and you're going to look at the file, inspect it, and come up with a plan. So as you can see now we can it says terraform will perform the following actions. Kubeadm demo VPC will be created, and then boom. So we've got DNS support set to true, DNS hostname set to true, blah blah blah, and these are all the other options that will be known after they've been applied. So the ARN, the default network ACL ID, blah blah blah, default route table, and all the rest of it. So we'll essentially just now run tf apply auto approve, and the reason is because when you run terraform apply, it runs terraform plan beforehand, and it prompts you to confirm whether or not you want to create the resources or destroy the resources. So it's creating. All right. So now we should have, hopefully, a VPCs, and as you can see, we have our newly VPC created with the correct IPv4 CIDR block. And as you can see, the default one doesn't have a name because it's untagged, but we've added a tag called name and uppercase N, and this corresponds to the actual name here. So this is good so that we can sort of at a glance see which one has been created by Terraform and which ones have been created manually. So now that we've got this, we need to create a subnet, right, for our resources to deploy our instances into, right? Okay, so fair enough. We'll go back and we'll do resource. We'll do resource AWS subnet, right? We'll call that kubeadm demo subnet, right? And then if we go to the documentation, so VPC, if we type subnet, right, we should have something here. Yep, AWS subnet, and then we'll copy that here, right? Actually, we don't need this, right? So we have to pass it a VPC ID. Ours is called kubeadm demo VPC, right? We choose a CIDR block. I'm fine with this one. And the name, we'll change that to kubeadm demo subnet. Again, so that we can recognize it. We'll come back here, scroll down a bit to argument reference. There's one thing we need to add, and it's map public IP on launch. We need our subnet to assign public IPs to our instances. Yep. Specify true to indicate that instances launched into the subnet should be assigned a public IP address. Default is false, so we need to set it to true. We'll go map, map public IP on launch, and we'll set that to true. We'll set that to true, like that. Again, we'll do TF plan to see if we have any issues. Right, doesn't look like we do. So we'll go TF apply, auto approve, and we'll wait for it to deploy. All right. So if we go back here and we go to subnets, at the minute, it's already created. I was going to show you that there weren't any subnets, and now we have one. And again, the name matches the name tag that we created here. So as you can see, it's very fast. Okay, so moving on, we need the internet gateway now to be able to allow our VPC to connect to the internet. So let's go and create that. So again, oops, where's my mouse? So I'll do resource like this. Oops, resource AWS internet gateway, and it's going to be kubeadm demo IGW like this. And let's go back to documentation, internet gateway. All right, and so we have to pass it a VPC ID, of course. Is it that? Yes, that's the one. So we've got the VPC ID, so we'll set VPC ID is going to be AWS VPC.kubeadm demo VPC.id, like so. And then we have to add a name. So we'll do tags name equals kubeadm demo IGW. So we'll stick to the nomenclature, right? Just for consistency. All right. So now that we have, let's actually create that. That's the last time I'll use TF plan. I'll just do TF apply next without the auto approve, of course. Okay, so we'll do TF apply auto approve now to deploy it. Let's see if it's faster. Okay, so now we've already got one at the default one. So it's creating. Now it's created. Let's refresh. Oh, what happened? Didn't apply the name. What the hell? Why didn't it apply the name? Oh, hello. Oh, it does have a name. I was looking at the wrong one. Okay, so yeah, so we've got a name, which is good. So now we need to create a route table. Again, we'll do resource, AWS route table, and it's going to be kubeadm demo route table. Like that. Oops. Brackets. Thank you very much. So back to documentation. Route table. So not interested in terms of gateways. This is what we want. Route table. Okay. So we'll copy all this. Actually, no. We'll copy the inside of this, like that. We'll paste this. All right. So VPC ID again. Oops. All right. So there's an issue with the spacing. Right. So our VPC is called kubeadm demo VPC.id. The CIDR block for the root in this case is going to be 0.0.0/0 because we want to allow traffic to and from the internet. We don't care about IPv6. We'll get rid of that. And gateway ID is going to be kubeadm demo IGW.id. What was it? ID? Yep. So it's IGW kubeadm demo IGW kubeadm IGW.id. Yep, that's the one. All right. And while we're at it, we will also associate that table to the subnet. So we'll create an association. Let's go to the documentation, and I see it here. Route table association provides a resource to create an association between a root table and a subnet on the root table on an internet gateway or virtual. Provides a resource to create an association between a route table and a subnet, or a route table and an internet gateway, which is exactly what we're going to do here. Right. Actually, no. That's the first one we need. Right. We need the first one because we need to associate that to the subnet. Oh, why is it not pasting? Right. There we go. Let's fix the spacing. All right. So I think it's called kubeadm demo subnet. Kubeadm demo subnet.id, and we'll call that kubeadm demo route association like this, and the route table ID is kubeadm demo root table.id, which we've just created here, as you can see. So that's for the route table. So let's do tf apply now, which is going to run tf plan, and we'll have to confirm that it actually works. Boom, there we go. That was fast. All right, moving on. All right, the last thing we need to do is we need to create a security group. So we'll have to create 4 security groups, and if we go back to the diagram here, we're gonna have one for common common ports like SSH and HTTP. Again, SSH, well, for obvious reasons, and HTTP and HTTPS. These are going to be used for pulling packages from the internet, and of course we need those for just a regular HTTP communication. We'll have a special security group for the control plane. We'll have a special security group for the worker nodes. And we'll have a special security group for the flannel container network interface. All right, so we need to create 4 security groups. So we'll do 1. It's going to be common ports. So SSH, HTTP, HTTPS. We'll have the control plane ports. We'll have the worker node ports, and then we'll have the flannel UDP ports. I think they're called backend ports, something like that. All right, so let's crack on with the security groups. Again, we've become familiar with the registry documentation, so we'll go and type in security group. There we go. Security group. Boom. There we go. So we've got tons of nodes. One thing that we need to take into account, where is it? I think it's egress, something like that. Terraform currently provides security group resource with ingress and egress rules defined inline, which manages one or more ingress. Both of these resources are added. There's something here. Oh, that's the one. By default, AWS creates an allow all egress rule when creating a new security group inside of a VPC, which is true. When you create a VPC from the console or with the CLI, you get 0 inbound rules. But all egress is allowed, right? So if you allow SSH in, SSH is allowed out, which is the difference between a security group and a network ACL, or access control list. And so by default, Terraform will override this. So if we want egress to work on a security group, we'll have to essentially explicitly define it as such. So this is only going to be apply to SSH and HTTP and HTTPS. We're not going to be doing this for the rest, but it's something to keep in mind if you're creating instances and you're creating security groups with AWS, and you need sort of two-way communication with your instances and the internet. All right, so we'll copy all. Maybe not. Do you know what? We'll create one here. So we'll do resource. Right. So the resource is going to be AWS. I think it's called security group. Yeah. Security group. And again, so we'll call this kubeadm demo SG common, right? So these are going to be about the common ports. All right, so we'll add ingress roles. Oh, first we need to give it a name, of course. So the name is going to be kubeadm demo SG common, right? Now, of course, oops, we'll add a tags and we'll add a name, which is going to be essentially the same as this, right? That's good. Now we'll need the ingress rules, and they're essentially objects inside of the main security group object, and careful not to add an equal sign here, because otherwise it's not going to work. All right, so ingress. Now what do we have inside of ingress? We have description, front port, blah blah blah. We'll copy all this. Oops. We'll copy all this and we'll paste that like that. All right, so this is going to be TLS. Okay, TLS from the VPC. Fair enough. Cider blocks. Cider blocks going to be the entire internet. So 0.0.0.0/0. We don't need IPv6 nonsense. What else? Protocols, TCP, and so we'll do the same thing for SSH, essentially. In fact, we'll call this allow HTTPS. We'll have another one for HTTP. That's going to be AT again, and we'll have one for, oops, let's copy this, paste, and we'll have allow SSH, and let's make it uppercase too, because why not? SSH is port 22 and not 20, like I did when I was testing, right? So this is good. We'll have one security group. Let's see if it gets created. So let's go back here, and then we should have something, yeah, under security groups. Now we've got default security groups created, but we will apply this configuration and see if we actually get our new security group. We'll apply this. Okay, it's done. Let's go back, refresh, and boom, we've got it. Great. So let's look at the inbound rules. And I made a mistake. Look, so I've got the inbound rules here, so 22, 443, and 80. The outbound rules, I have got none. And if we go to this default security group, we have all traffic protocol, all ranges, destination, internet, right? So we need to come back here and add an egress block and copy that from the documentation like this. So hopefully now we should be able to, now if we do apply, it shouldn't say create, but we'll have 0 to add, 1 to change. Yeah, 0 to add, 1 to change. So we'll say yes. Did it create? Let's see if it updated it. So inbound rules, outbound rules, right? So now we've got the correct outbound rules. So one is for IPv6 and one's for IPv4. We don't really need the IPv6, but whatever. Okay, in fact, let's just get rid of this. All right, so we move on to the control plane ports now. And how do we know what ports to open? Well, the Kubernetes documentation tells us what ports should be running. So when running Kubernetes in an environment with strict network boundaries, such as on-premises data center with physical network firewalls or virtual networks in public cloud, it is useful to be aware of the ports and protocols used by Kubernetes components. So we will, these are all inbound ports, so we're not going to need an ingress role. So we'll crack on with this. So we'll have the port for the kube API, for the kube scheduler, the controller manager, the API server, and an etcd, which is the database that's been used by Kubernetes. All right, so let's go and create that resource. Again, AWS subnet. We'll call that kubeadm demo security group. It's not a subnet, it's a security group. What am I doing? Security group kubeadm demo sg control plane. Right, and you know what? We'll copy this. Boom, and we'll paste that over here. So this is going to be control plane. Alright, we'll get rid of this. Okay, so we've got 1, 2, 3, and 4. So 6, 4, 4, 3. 6, 4, 4, 3. That's good. This one is the kubelet API. Right. The kubelet API, and kubelet API runs on port 10250. Oops. So it's 10250. We've got the kube scheduler, right? Kube scheduler, and this is 259. Oops. 259. We have got kube controller manager on port 257. 257. Oops. 257. What's going on here? What is going on here? Boom. 250, and then we've got etcd. Copy this. Nope. etcd. etcd. Oh my god. etcd. Thank you. In fact, etcd server client API, and so this is a port range, so it's these two, right? So we'll do 2379 to 2380. There we go. Now we don't need, again, egress because they're all inbound only rules, right? So once we're done with this, let's apply that first and see if we get any errors. df apply. I think I messed up the name, didn't I? Oh no, name's all right. Okay. So that security group has been created, which we'll verify later. We just need to move on now with the resource AWS security group. This one's going to call kubeadm demo sg worker nodes. Right, and for the worker nodes, we've only got two. So kubelet API and service API. So where is it? Kubelet API. We'll copy that one. We could have it in its own security group and then sort of apply to both instances, but you know, I'll do ingress here again. Description. It's going to be this. So no port services. We'll copy that. And so the port range is going to be 30,000 to 32,767. Oops. And the reason is because these are going to be used by the node port services. When you create a service in of type node port in Kubernetes, it runs on high port, so between 30,000, 32,767, and then you can essentially access the service using the public IP of the node that the service is running on. So this is good. And then we'll go to the Flannel, and I've got the documentation pulled up here, and I came across this because I banged my head against the wall because it wasn't working. So communication between the pods inside the cluster just wouldn't work. So now I've got this solution, which comes from K8s. And as you can see, port allocation, the information below describes the minimum set of port allocations used by Kubernetes components. Some of these allocations will be optional depending on the deployment, e.g. if Flannel or Calico is being used. Additionally, there are likely additional ports the deployer will need to open on their infrastructure, blah, blah, blah. But for this, so we've got 443, which is good. But we're going to need 2 UDP ports, inbound, of course. And we also have to add this to the worker node. So inbound 82, 85. Right. So we'll create that. We'll go resource, AWS security group, kubeadm demo sg flannel. All right. So now let's apply this and see what we get. And I think that's the last step for the networking components. And then we'll be able to move on to the instances. So let's see, let's apply it. All right, create a value. So we'll see, yes. Come back here. So let's look at security groups we have. All right, so we've got control plane. Oh, wow. That was fast. So Flannel, let's look at the Flannel one. So inbound rules, UDP, it's only got 1, we need 2. Okay, so we will reapply this, which is going to update our security group, and we'll be able to see that it was actually updated. All right. There we go. If we come back here and then refresh, we've got 2 now. So IPv4, UDP, 8285, 8472, source as the internet, and UDP backend and UDP VXLAN backend. So I think we've got everything now when it comes to the networking components, right? Because we've attached the route table to the subnet. It makes it de facto a public subnet. So we're going to create 3 instances. So 1 control plane, 2 worker nodes. We'll create a key pair, and then we'll use Ansible to provision these machines to be able to install kubeadm and start playing around with Kubernetes. So I'll catch you in the next chapter. So we've got our networking infrastructure set up, right? So it's time now to create the EC2 instances. So we'll create the nodes, but before that we need to create a key pair, right? Because we want to SSH into these instances. So we're going to have to create a key pair directly from the Amazon console. So we can go again into VPCs. Actually, no, it's not VPC, it's EC2, right? So we need to go and look for EC2. So inside the EC2 dashboard, we can go, and as you can see, you've got 0 instances running, 0 elastic IPs. Let me zoom in for you. 0 instances, everything's set to 0. I've got 6 security groups, including the 4 that I have created in the previous section. But if we scroll down to network and security, we find key pairs, right? And so I've got no key pairs now, so we can create one, but we'll use Terraform for this. And so as usual, boom, we'll go back to the Terraform registry, documentation, and then we'll search for key pair, like that. So as you can see, EC2, resources, AWS key pair, and then we can create a key pair like that. Right, so we'll copy this. Of course, it needs a public key. So we're done with the networking related resources. So now we'll make some space for the instance related resources. So we'll go resource, AWS, what's it called, key pair, key, resource key underscore pair, I'm going to call this kubeadm demo key, like that, right? So I'll just copy that, the key name, right? Now, we're not going to worry about this. So for the key name, I want this to be a variable, and we've created a variables.tf file, if you remember. So we'll open that, oops, in a new tab, a new pane, sorry. And so we'll create a variable, right? So we'll go variable, I think it's called, we just give it a name, right? So variable, let me check. Yeah, it's just variable, and then we give it a name. So in our case, it's going to be kubeadm demo key name, right? So the type, property type is going to be string. We can give it a description, I think. Yep. And so the description is going to be name of our key pair, like that. And then we'll pass it a default value. And we want our name to be called kubeadm demo kubeadm _demo _key, like that. As you can see, I get a warning saying variable key demo key name, kubeadm demo key name is declared but never used. Well, we'll solve that right now. We'll go back here, and then instead of hard coding the value, we'll go var dot kubeadm demo key name, like that. And as you can see, the warning is gone. So there's that. Now there's the issue of the public key, right? And so for the public key, we can create, there's a provider in the Terraform registry that allows us to create keys. So we'll do that. It's called TLS, HashiCorp TLS. What is it? Yep. Oh, there we go. Okay, so we'll copy this, right? We'll copy just that bit right there, because we already have, if we go back up, oops, go all the way back up, we already have the required providers bit. So all we have to do now is add this, right? So now we've added this new provider. We have to download it. So we need to run terraform init or tf init. Default is not expected here. Of course, it's not default value, it's default. Boom, like that. Now we can run tf init, and it will download the download the provider. So we're good. Let's go to the documentation, resources, and I think, if I'm not mistaken, it's private key. Yeah, that's the one. All right, so the way we're going to do this is we're going to create an RSA key, like that. So I'll just copy that bit, right? So we'll create a key. Oops, we'll create a key here. Oops. Let me fix the indentation quickly. So this is going to be kubeadm demo private key, right? So we've got, so we create a private key of type RSA and of size 4096. We pass the algorithm and then the bits, and then we can pull the data, right? So we can go we can pull the public key, and we can pull the private key PEM, I think. Yeah, right. So private key data and public key data, right? So we're going to need the public key data for this. And so for the public key, oops, let's go back. The public key, right? We will need TLS private key, that kubeadm dot the public key OpenSSH. And the reason is because there's another one I think for use for putty, right? But we don't need that because we're going to be using an Ubuntu instance. But don't quote me on that. So okay, so we've got the public key, but unfortunately, so now we create a key pair, but we need to, of course, have access to it physically because we're going to need to use it to connect to our instances, and Ansible is going to require it to provision the nodes. So we'll launch what is called a local exec provisioner, and so this is a command that's going to run locally inside our machine, right? So we'll pass the command like so, and then what we want to do is we want to echo, right? We want to echo, right? Self dot public key pem, right? And so we want the public key, echo public key, and so we'll send that over to pubkey.pem like that. So this is going to take the public key. Actually, we don't need this here. We need this bit needs to be here, right? So we get the public key that is generated from the private key, and then we essentially output it into a file. And now what we want to do the same here, but with the private key, right? So this is what we're going to do. We'll go echo. We'll do TLS private key dot private key pem. Hang on, no, it's called kubeadm demo private key. I'm going off of my notes here. kubeadm demo private key, and then of course we want to extract the private key pem this time. So private key pem, right? And we want to send that to private. We'll call it private key, whatever, private -key.pem. Right. So we've got the demo. So we've got the AWS key pair and the private key, right? And so once we run this and apply and run terraform apply, we should have a public key and the private key. All right. So let's do that. Let's do tf apply. Right. As you can see, the public key has been outputted. All right. So let's ls into the directory to see if we have, okay, so we have a public key and we have a private key. So if we do la, the public key and the private key have, so they're not empty, judging by the size, and the private key is a bit more, has a lot more data, quite clear. We need to change mod 400 for the private key, right? And then I think that's it, right? So we've got the key pair, we're good. Now we need to create instances. So we are going to first create the control plane, right? So that's going to be essentially an instance, right? So if we go back to the documentation for AWS and we type EC2 instance, AWS instance, right? So resource AWS instance web. That's what we need really. Spot, and we don't need spot instance. We're not going to be dealing with CPU options, right? But we'll have to add a few options. So we'll copy this, right? Like that. Nope, I want to search DuckDuckGo for this. Okay, so I'm going to create a resource called AWS instance, and that's going to be kubeadm demo control plane, right? Okay, so it's going to have an AMI, as you can see. So we'll have it. So for the name, we'll go kubeadm demo control plane. Instance type for this is going to be T2 medium, because again, based on the recommendations for from Kubernetes, if we go back, 2 gigs of RAM per machine or more, and 2 CPUs or more, right? And so the cheapest instance that fits the bill, fits the description, is the T2 medium. And again, it's not going to cost us much. I think less than 5p, because we're not going to be running it for more than 10 minutes. So I think you're billed for an hour anyway, like even if you don't exceed an hour, but you know, it's 5p. So right, so and then we need to go back to the documentation, because we are going to need to add a few more options. So the AMI, as you can see, first of all, is pulled dynamically, which means we're going to have to create a variable called kubeadm demo AMI, right? So type, again, is going to be string. The description is going to be AMI ID for our Ubuntu image, and the defaults, well, for the default, we're going to have to go to EC2, go to AMIs, AMI catalog, I think it is, and I think this is the Ubuntu one. Let's go to Ubuntu server, that's the one. So we'll copy this ID, oops, that's the AMI we want, right? We'll come back here, and then we'll paste it. Oops. We will paste the AMI. And so instead of doing data, we'll get it from var kubeadm demo AMI, like so. Right. So we got the AMI. Okay. Because we've created a key pair, we're going to need to associate a key pair too, right? I think it's key name, right? Key name of the key pair to use for the instance, which can be managed using the AWS key pair instance resource, which is good because that's what we want. So we'll go key name, and that's going to be TLS. Actually, no, that's not it. That's going to be the AWS key pair. Boom. Dot key name, if it allows me to key. I'm just gonna type it by hand. Key name. Okay, that's good. We also want to associate a public IP address. If we go back up here, right, whether to associate a public IP address with an instance in the VPC, we want that. So we'll go yes, associate public IP address, and that's going to be true. We need to add the security groups, right? So security groups, like so. That's going to be a map or a list. So for this instance, so everything is going to apply essentially. So security, oops, AWS security group. So what did we call it? Let's go back up. that. It's great. What else do we need? What do we need? We'll set up a root block device too, because I think by default you only get 8 GB, but I want to give it 14. So let's go to root block device configuration block to customize details about the root block device, like this. And so volume size and volume type. So that's going to be very easy, and it's a class inside of the resource. So root block device, and so we'll have a volume size of 14 and a volume type of I think GP2, the SSD volume type. Okay, and so once we're done with this, essentially what we want to do is we want to you'll see when we get to it, but we want to output the IP address, the public IP address of the control plane in a file called hosts, right? So you'll see when you get to the Ansible bit, but first let's create a directory called files, right? And so now we'll do the same thing we did for the key pair. We'll do provisioner, right? Local exec, and there's a bunch of provisioners, but there's remote exec too, I think. And so for now, what we want to do is we want to have a command, and so we want to echo master. Again, we'll explain this in a bit. Self.public IP, right? And we want to send that over to files hosts, like this. Okay. So if we cat files hosts, well, we don't have a file. We don't have a host file here. But if we do tf apply now, hopefully we've not made any errors. And we did. An input variable with name has not been declared. kubeadm demo AMI. We have created that. Oh, maybe we just didn't save the file. Fair enough. Yes. So as you can see, it's going to create a root block device, 14 GB, and inside the free tier you have access to 30 gigs for free. So we're not going to exceed that. The only thing that's going to cost us money really is the instance, and that instance alone, because the worker nodes are going to be free. We'll use the T2 micro. We'll use a T2 micro instance type, which is part of the free tier. So nothing to worry in that respect. Nothing to worry about in that respect. It's done. Now let's check the hosts file and see if we actually have something. Yep, cool. And so the IP address matches that of, as you can see, auto-assigned IP address 54.226.193.163. So that matches, which is good. It's great. All right, moving on. So now we've got the control plane. We need the worker nodes now. So we'll do essentially the same thing with a few adjustments. So we'll create a resource again, AWS instance, and that one is going to be called kubeadm demo worker nodes. Okay, so what did we have? We'll add the tags, right? So we'll name them. We're going to need 2, right? So we're going to need a count for this. It's a special variable, it's a special construct in Terraform that's used for looping, right? So we'll create a count, right? And we'll do 2. Now we want this to be variable, so we'll go variable cube kubeadm demo instance count. Oops. That's going to be type number. Description is going to be the number of worker nodes in the cluster, and the default is going to be 2. Right. Again, we can have as many as we want really, because they're going to be T2 micro, and we're not going to have to pay a penny for them. So we've got 2. The AMI is going to be much the same, so var kubeadm demo API. The instance type, actually, do you know what? Let's make that a variable too. So we'll go variable kubeadm demo instance type. Let's call it worker instance type. Worker instance type. So this is going to be a string. The description is going to be the instance type of our worker nodes. Right. The default is going to be T2 micro. Like that. Okay, so that's going to be kubeadm demo instance count, right? And instance type is going to be var dot kubeadm demo worker instance type. And why is this not kubeadm demo instance count? Oh, no. So this is the kubeadm demo instance count, and that's the kubeadm demo AMI. I'm doing the other way around. All right, so we have to add the key name. Again, so key name is going to be, what was it? The key name was AWS key pair. So AWS key pair dot, let's see if we have it here, dot name dot key name. Sorry, key name like that. Again, associate public IP addresses are going to be true, so associate is going to be true like that. And the security groups are going to be very much the same, except we will have the we'll switch to control plane with kubeadm demo SG. What did we call it? I think it was worker nodes, right? Oh, what was it called? Oh, it was called worker nodes, right? kubeadm SG worker nodes. Like that. So we've got the common, the worker nodes, and the flannel. So we've got security groups, and then we'll set the root block device settings. Again, we want a bit more than 8 gigabytes. Actually, do you know what? We'll leave it at that. We'll leave it at 8 gigs. It's fine for now. It's just a demo, really. But realistically, you'd want to, you know, add a bit more storage. Okay. Oh, and of course, we need to copy the IP, the public IP. And so now we're going to do a bit of magic, right? So we'll go worker hyphen, we'll get the count.index, right? So we'll have worker -0, worker.1, worker.2, blah, blah, blah. And then we'll pass the self.public IP, and the tag is going to be, the name is going to be worker index, oops, string interpolation, like that. And the role, I think it's going to be worker node, whatever. And we'll add a role to this too. We'll call it control plane. Okay, so this should create, our worker nodes, 2 of them. Let's see. All right, so let's see if it's done. Not really. Oh, it is. Okay. So hopefully we should have something. All right, so we're not gonna wait for the checks to pass, because they will pass anyway. We just want to first check the host file, as you can see. So we've got all the IP addresses. So what we want to do, just as a quick test, we want to SSH, right? So we'll pass it the private key as an identity. So SSH-I means give us the private key. I stands for identity. We'll log in as Ubuntu at 54.226.193.163. That should work. So the authenticity of blah 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 can't be established. Are you sure you want to continue? Yes. And we are in. Boom. Now there's a bit of lag. Don't know if you've noticed this. That's because they're in the US and I am in Western Europe, so there's a bit of a distance. Let's do that for, just to check, for sanity check. Let's go SSH-I, and then we'll try and log into the other one. So 205.158.31. Yes. And we are in. Good. Oops. Again, so that was worker 0, right? And as you can see, it displays the private IP address of the instance as the host name. We'll change that when we get to Ansible. And SSH private key .pem, and this time we'll go to worker 1. So 205.78.52, like that. Again, yes, and boom, we are in. All right, so the key pair functioned properly, right? It works. The instances have been created successfully, so now we can finally move on to provisioning the instances and installing kubeadm. So now the architecture, the AWS bit, sort of the architecture, everything has been created. So we're good now. All there is for us to do is well, provision these instances, because right now we don't have Kubernetes running on them, and we don't even I don't think we even have Docker running on them. So we'll use Ansible for this, and I'll catch you in the next chapter. All right, so now we're going to get into the meat and potatoes of this whole project, and that is to install Kubernetes and set up Kubernetes with kubeadm inside of our newly created EC2 instances. So we could do all of this manually, right, and follow, because essentially it's not really that difficult. The Kubernetes documentation is very clear and very easy to follow when it comes to setting up kubeadm and installing the prerequisites. But I've taken the liberty of creating an Ansible playbook, which you will be able to find on GitLab, and maybe GitHub if I remember the password for my GitHub account. But it's going to be on GitLab. I'll leave a link down below in the description. You'll be able to check it out and follow along. I'm not going to, write it down from scratch, because it's already sort of created. So I'm just going to run you through essentially the main bits of it, and then we'll read along and I'll explain what everything does. So let me first of all save this, right? But before we get to the Ansible and the playbook part, of course we need to use the Ansible provider, and this is a newly created edition. So let's see, Ansible providers. I think it was, yeah, Ansible by Ansible. So that's the one. We'll create that. So we'll copy this bit. You know the whole dance now. We've done it before. So we copy that here like this. Save, and then we tf in it to install it. Right. Okay. All right, so it's installed. It's good. Clear this. Okay, so let's have a look at the documentation. So we don't care about vaults. We're not going to care about that. We are going to create a host. Right, so we're going to create a host, and an Ansible host is essentially, you know, I guess you could say the representation of a server, right? A remote server that you want to run the playbook against. It comes with a set of variable, and this is essentially going to populate a what's called an inventory file. And there's a great blog post. If we go Ansible, I think it was Ansible terraform provider on Red Hat. Yep, or Ansible.com. Sorry. There we go. Right. So it walks you through how this all works. And if you notice here, there's this bit called plugin, right? Cloud Terraform, the Terraform provider, and that's a collection that we're gonna have to download. So we'll do that. We'll create an inventory file first. So let's touch inventory.yaml, right? We'll open that and paste this. We'll add the 3. We don't have to do that, but just for consistency. And so now we need to go to Ansible Galaxy /cloud/terraform and copy this and just paste it here and run it. Okay, so I've already got it installed, but you'd have to run that, and then it will install for you. So going back to the documentation, now we can essentially create our host. So we'll do one for our control plane, and another one for the worker nodes. So let's crack on with this. Let's go back to the code, go to main.tf, and inside of here we'll create a resource, right? We'll call it Ansible host, and we'll call this kubeadm demo control plane host, right? Like that. Okay, so this is going to depend on, depends on variable, depends on declaration, and that's going to depend on our instance. So AWS instance dot kubeadm kubeadm demo, I think we called it control plane, right? What did we call it? Yep, kubeadm demo control plane. Control plane, like that. So the name, we're going to give it a name, just going to call it control plane. And this is going to have to match some of the data that we're going to have to put inside our playbook. Groups is going to be master, as in master node. Again, you can call that whatever. Now we're going to need some variables here. One is going to be the Ansible user. Right, it's called Ubuntu. The Ansible host. Right, it's going to be our AWS instance .kubeadm demo control plane dot public IP, right? Because of course it needs the IP address to be able to communicate with the server to install all the programs and install all the necessary libraries and what have you. We need a path to the private key, because again it's going to do it by SSH, so Ansible SSH private key file, and these are variables that are baked into Ansible, right? So what did we call it? We called it pub key. I think we called it private key, right? Private hyphen key dot pen, like this. And the node host name is going to be master, and this is going to have to match the host's file like this. So we'll do this for the control plane, and we'll do the same for the worker nodes. So kubeadm demo worker nodes host, and that's going to depend on kubeadm demo worker nodes. Yep. So now the name, actually we're going to have two, so we're going to have to add a count of 2. The count is going to be the same as kubeadm demo instance count, and so the name now is going to be worker dash count.index, right? The groups is going to be workers, and the rest is going to be much of the same, really. I think the name, so the node host name is going to be this, right? Worker dash 0, that one, blah blah. The private key file is going to be the same, and so for here, what we need is, so we need to pull, because we have 2, we're going to have to do some Ansible kung fu, right? So we'll do kubeadm demo worker nodes, right? We'll pull count.index because it's a list, and then we'll pass the public IP like so, right? And so this should create, hopefully, if I tf apply, this should create or populate the inventory file for us. All right, so I've run into some technical difficulties, but I am back now. And so I essentially applied, so I did terraform apply with the newly created Ansible host resources, right, like this. And so if we run Ansible -inventory /i inventory.yaml -graph, we should have a dynamic inventory file, right? And as you can see, they correspond to the groups that we've created here. So control plane is part of the master group, and then each worker node is part of the workers group, right? That's good. I have a playbook right here, and here we can. So I'm gonna get rid of this. Let me zoom in. Right, and we will walk through essentially each section one by one, and I'll tell you what each one does and why it's important. So it's a basic playbook, so we don't gather the facts because we don't need to for this. This is going to be run on all hosts, right? Irrespective of their group. Become essentially means become sudo, right? So become a super user. All right, so first thing we need to do is we wait. So we use the built-in wait for command, and we wait for 200 seconds for port 22 to become open, right? So this is really just for maintenance. Now we set the host name, and the reason why we set the host name is because if you remember, we have a file called hosts, right? And so each host name is going to have its own. Each host is going to have its own host name, and that's going to be able to. That's going to allow each node to be able to sort of, communicate with their DNS names. And this is exactly what we're doing now. We're copying the etc host template into the into each instance at /temp/host, and then we update. We update the configuration. We update the local etc host with our new host file. So what it's going to do is it's going to append essentially these lines to the etc host file inside each instance. We also disable swap, and if we go to installing kubeadm, I think if we go all the way back up, swap disable. You must disable swap in order for the kubelet to work properly. For example, sudo swap off -a will disable swapping temporarily. To make this change persistent across reboots, make sure swap is disabled in config files like etcfs and blah blah blah. But again, we'll do this. We'll just do swap off -a for now. Now these next three bits, right? 4 bits, right? So we've got kernel module prerequisites, and then we were adding kernel modules, overlay, and brnet filter, and these are prerequisites for the container runtime, right? If we go all the way back here, install configure prerequisites. The following steps apply common settings for Kubernetes nodes on Linux, blah blah blah. And so we essentially, these are just essentially copy paste of that bit, right? So if we look, see that, and then we do mod probe overlay, mod probe brnet filter, like that. And then we add this bit, right? sysctl params required by setup, params persist across reboot. Boom. Then we run sysctl --system. Okay. Then what we do is we create a containerd config file that we are going to then populate. So this is run inside of each instance. So at etc/containerd/config.toml. We install the containerd prerequisites. So cs certificate, curl. Actually, I have it twice. GNU PG, LSB release, blah blah blah. Now we install Docker too, right? The Docker GPG key. We add the Docker repository. We update the cache, and then we install Docker C. So this is essentially the equivalent of doing sudo apt update and sudo apt install, blah blah blah. We install containerd, the package containerd. We enable it. So this is the equivalent of doing systemctl enable containerd. So we set up containerd to use systemd as C group, and again, if we go here, C group drivers, where is it? That's the one. To use systemd C group driver in etc containerd config.toml with run C, set this, right? So we have created an etc containerd, that's the one. So I have a template that contains this change here, right? And what we're going to do is we are going to copy that over, right? So we take the files, so we go to /files containerd config, and then we essentially pop that into etc containerd config.toml. Then we restart containerd, right? And we also issue daemon reload to pick up the config changes, right? So these are all the prerequisites before we do anything with kubeadm, right? Now we do the kubeadm stuff, and so we download the Google Cloud's public key, right? We add the Kubernetes repo, and then we install kubeadm, kubectl, and kubelet. And if we come here, blah blah blah, so installing kubeadm, and so we do sudo apt update, sudo apt install, apt transport https cs certificate. So we've got these ones already. So we download the Google Cloud public signing key, we add the repo, we update, and then we install these three packages. Now this is going to install the latest version, but we can lock also the version. But what we're going to do next is we're going to hold these packages, and that's going to essentially prevent us from upgrading the version when we run sudo apt update or sudo apt upgrade, right? It's going to return an error, I believe, saying that these packages are on hold, right? So now that we've got kubectl, kubeadm, and kubelet installed on all nodes, we can set up the master node, right? So essentially the control plane. Let me call it control plane node, right? And so as you can see now, the host parameter is set to master. So whatever's below here, all these tasks here, right, that are indented, are only going to be run against the master group, right? And there's only one node in the master group. If we come back here, as you can see, if it cooperates, yep. So control plane, master group, control plane. So we've only got one, right? But if we had high availability, we'd have many more. So what we do now that we have kubeadm and the kubectl and kubelet installed, we initialize kubeadm. So we do sudo kubeadm init. We pass it pod network CIDR. So this is a sort of CIDR block for the pods. We set it to 10.244.0.0.16, and then this bit is very important, at least on AWS. It's the control plane endpoint. If you don't set this, essentially what's going to happen is it's going to use the private IP of the control plane to advertise the control plane, and that's not what we want. What we want is, I mean, it's okay if you run I guess your Kubernetes cluster inside within your VPC and it's not connected to the internet, but for us, we want to advertise the public IP, so we'll set it to the Ansible host :6443, right? If you don't do this, you're gonna run into problems. We create the home.kube directory, we set the correct permissions, then we copy the default kubeconfig file, right? So that's generated when we initialize kubeadm. We set the correct permissions on the kubeconfig file, and then we install Flannel. Again, Flannel is a CNI, so container network interface. Right. Flannel is a simple, easy way to configure a layer 3 network fabric designed for Kubernetes. So it's very good, and we should use that. There are many more of these, but I've just picked this one because this is the one I'm familiar with. And then what we do is we copy the kubeconfig file locally, right? So the kubeconfig file that was created inside the control plane node, lives inside the control plane node, and we need that kubeconfig file to be able to interact with our cluster locally. So what we do is we copy that to /dem/kubeconfig, and then we generate a join token for worker nodes. So what's going to happen is essentially every worker node is going to have to run a command to join the cluster. Right? So the cluster is created, but now the worker nodes haven't joined yet. And so what we do is we create a token, a join token, right? And so we run sudo kubeadm token create -- print join command, and we register the output of that command inside a variable called join node token, right? And what we do is we set a fact. So we use the built-in set fact command provided by Ansible, and then essentially we get a variable here that corresponds to join node token dot standard outlines 0, right? And so this is going to be essentially the output, the join command output that's going to be run by every single worker node. And as you can see below, we set up the worker nodes. The host group is going to be the workers, and then here what we do is we pull the host vars of the control plane, right, of the control plane node, and then we extract the join node variable, right? So this is going to be a variable that is going to whose value is going to correspond to the output of this command, right? And so each of these worker nodes now is going to be able to join the cluster. So let's run it, right? Let's do Ansible playbook /-i inventory.yaml playbook.yaml. We'll run that and see if we run into any errors. And it's essentially going to go through task by task, right? All we have to do now is wait, see, okay, and get the status for each task. Now we're setting the host name, we're copying the host template. All right, so now we're setting up the control plane. And we're initializing kubeadm. It's taking a bit of time. Okay, so we're creating the kube directory, kubeconfig. All right, we're installing flannel into the cluster. We're copying the kubeconfig file. We've generated join token. Now we're setting up the worker nodes. As you can see, it's only doing this against worker 0 and worker 1. Boom, okay, so we're good. The playbook is finished running. We can check that we have a kubeconfig file, and we do. And if you look at the server now, right, 3.84.137.72, hopefully this should match the master IP, and it does. And if you've noticed, the IPs have changed because I took down the infrastructure and put it back up due to the technical difficulties I experienced. Okay, so now that we have this, so we've got the kubeconfig, we are going to set kubeconfig to this, the kubeconfig environment variable, to /dev/kubeconfig/config. I'm on fish, so this is how it's done. If you're on bash, you'd probably want to do something like kubeconfig equals blah, right? Something like that. For me, it's this. And so if I echo kubeconfig, okay, so I've got that. Great. So now we can test that everything's working. So I can do k get node, k for kubectl. All right, so I've got the master, worker 0 and worker 1, so they're all ready. Let's see if we can create a deployment. Let's see, let's go create deploy demo. Image is going to be nginx alpine, and I think replicas, right? So replicas equals, let's create 3 replicas, whatever. Right, I think that's it. Okay, so if I do k get deploy, okay, so we've got 1 out of 3. Okay, so 3 out of 3 are ready. K get pod, all the pods are running. Great. So now we can expose that. So I can go k expose deploy. Nope. K expose deploy. What did we call it? Demo. Right. Demo, and give it a name of demo svc. Okay, so if I do k get svc, so I've got my demo service. right? So now I should be able to run temporary. I should be able to run a temporary pod and curl the service, and it was called demo service. I think it ran on port 8080, right? And it works. Would you look at that? Let's see if we can create a node port service. Let's see. I want to check. Right, so let's see. Let's create one. Let's do kubectl create svc node port demo node port, and then we'll do TCP. I think it was 880. Well, let's go 8080, and then node port. Is it node port in one word? Yeah, node port is going to be 31,000, because if you remember, the range was between 30,000 and 32 and some change. So we'll do that, right? And if we K8s svc node port demo node port, okay. So the selector is going to be app. What did we call it? What did we call it? What did we call it? K8s deploy demo. I think it's -L. No. K8s deploy -L wide. Selector app demo. Yep. All right. So let's get the selector app demo. So this should hopefully K8s services. Let's delete the other service. So K delete svc demo svc, right? K svc. Okay. So now K8s svc. Let's see if it works. Cats, the files, hosts. Let me curl /31,000, and it works. Boom. All right. Well, I don't know why I'm not seeing external IP here, but that's fine. I'm a bit rusty when it comes to my Kubernetes and kubectl knowledge. I haven't really used Kubernetes in a few weeks, so yeah, I'm a bit rusty, but it works. So everything's working fine. In fact, let me copy this and paste it in the browser just so we can actually see it with our own two eyes. Boom, we've got a welcome to Nginx. Brilliant, brilliant. All right, well, I think that's it for our little adventure in cloud automation with Ansible and Terraform. If you have any questions, pop them down below in the comments. I will be most happy to interact with you. Again, you can find me on Twitch, AOFisher. You can find me on Twitter at AOFisher. You can subscribe to the channel. You can like it if you've enjoyed the video. I'll see you in the next one, where we will do all of this, right? All of that good stuff, but exclusively using the AWS CLI. We're not going to be doing Terraform. We're not going to be doing any of that. We'll keep the playbook, and we'll keep the Ansible bit, but we'll do the whole thing manually. And before I leave you, of course, we need to destroy the infrastructure. So we can do tf destroy and go to our console, right, and verify that everything is going to. I don't want cookies. I'm going to diet. All right, so let's let it load. Okay, so as you can see, we've got these are previous 3 that I terminated. And so now I am going to destroy this infrastructure, and then we'll see it go. Yes. So it's essentially tearing down the whole infrastructure in one go, which is one of the main benefits of using Terraform and things like CloudFormation and stuff like that. Pulumi too, I've never used it. Maybe I'll do a video on Pulumi. Alright, so it's destroying, blah blah blue. Okay, so now it's destroying the nodes. So if I refresh, yeah, shutting down, terminated. It's taking a bit longer to shut down the master node. And you want to destroy this, especially if you're doing, like, if you're testing stuff and if you're running dev environments, because you might, you know, wake up one day with a massive AWS bill, depending on the type of resources you're using. In our case, it's fine because we're not really doing much. But yeah. So it still hasn't finished. I think it's waiting for the terminated status to continue. Yep. All right. So it's done that. Okay. So if we go to security groups, we shouldn't have any anymore. Yeah. So we've only got one. Key pairs have been destroyed too, I believe. Oh, this one hasn't been destroyed. Oh, that's the one we created the first time. So we haven't got any load balancers and blah blah blah. Let's go to VPC. See what we had. I think we had, well, the entire VPC is gone essentially. We've only got the default one. Yeah, we've only got one. So that's the only one. It's the default one. The subnet. All of them, all of these are the default subnets that come with the default VPC. Internet gateways, we have none. I mean, we have the default one that's attached to our VPC. The route table again is the main one, as you can see, main, yes. Security groups, we don't have any. Yep, we've only got the default one. And so I think that's it. Yeah, it's all been torn down. So we're safe, and with that I wish you a good day and good night, and I'll see you in the next one. Cheers.